You know, I was standing in my office at 3 in the morning when the data came through, and I felt something I haven't felt in 40 years of physics research. My hands were actually shaking. Not from fear, but from the recognition that we were witnessing something that would fundamentally rewrite what we thought we knew about our cosmic neighborhood. Let me tell you about 3I Atlas. This isn't just another space rock passing through. This is an interstellar visitor, only the third confirmed object from beyond our solar system, and it's doing something that has every physicist, astronomer, and space agency on Earth watching with a mixture of wonder and concern. It's disrupting satellite orbits in ways we've never seen before. Trajectories that should be predictable within millimeters are suddenly off by meters. Communication systems are experiencing unexplained delays, and the most unsettling part, the math we've used for decades to predict celestial mechanics is failing us. I want you to understand something crucial right now. This isn't about doom. This isn't about fear. This is about standing at one of those rare moments in human history when the universe taps us on the shoulder and says, "Everything you thought you understood, it's time to think bigger." I've spent my entire life studying the fabric of reality, from superstring theory to parallel universes, and I can tell you with absolute certainty that moments like this don't come along often. The last time we had a comparable paradigm shift was when we discovered that the universe itself is expanding, that everything is moving away from everything else. That discovery changed not just physics, but philosophy, theology, how we see ourselves in the cosmic story. And now, this visitor from another star system is showing us that we've been making assumptions, dangerous assumptions, beautiful assumptions that made the math work perfectly until they didn't. You see, when you calculate satellite trajectories, you assume you know all the gravitational influences, Earth, Moon, Sun, even Jupiter's massive pull. It's a symphony of forces we can predict with extraordinary precision, except something is adding a note to that symphony that we never heard before, and that note is coming from 3I, Atlas. What terrifies and excites me in equal measure is this. If a single interstellar object can disrupt our carefully balanced orbital systems, what does that tell us about how little we actually understand about what's moving through the space between stars? You see, for decades, we've operated under a comforting assumption. We believed that interstellar space was essentially empty, a cosmic desert with occasional grains of sand drifting through. But what if we've been fundamentally wrong? What if the space between stars is actually teeming with objects we simply haven't detected yet? Think about it this way. Before Oumuamua arrived in 2017, we had detected exactly 0 interstellar objects. 0. Then suddenly, within just 6 years, we've confirmed 3, maybe 4 candidates. That's not a coincidence. That's a sampling problem revealing itself. It's like standing on a beach at night with a single flashlight and concluding the ocean is empty because you can't see the fish. The moment you add more lights, suddenly you realize the water is full of life. The mathematical implications are staggering. Based on these few detections, astronomers now estimate there could be trillions of these objects passing through our solar system at any given time. Trillions. Most too small or too dark to detect, but they're there, invisibly threading through the space between our planets, like invisible currents in an ocean we thought was calm. And here's where it gets deeply unsettling. We know 3I Atlas came from somewhere. Every trajectory has an origin point. When astronomers traced its path backward through space, accounting for the gravitational influences of every star it might have encountered, they found something disturbing. Its origin is ambiguous. It didn't come from any nearby star system we can definitively identify. It emerged from the general direction of the galactic center, from a region so crowded with stars that pinpointing its birthplace is nearly impossible. Imagine receiving a letter with no return address, written in a language you barely understand, telling you something is coming. That's essentially what we have here. We know this object was ejected from some planetary system somewhere at some point in the past millions of years. But we don't know where, we don't know when, and most critically, we don't know why. And here's where it gets unsettling. When you look at the trajectory data, the velocity at which Oumuamua was moving, it wasn't just drifting, it was hauling. We're talking about 87 kilometers per second relative to the Sunday. That's fast. Extraordinarily fast. But speed alone isn't what made scientists pause. It's the fact that this thing was accelerating. Not a lot, but measurably. After passing the Sun, Oumuamua sped up in a way that couldn't be fully explained by solar radiation pressure alone. Now, comets do this. When ice vaporizes from a comet's surface, it creates a tiny rocket effect. But remember, we saw no tail, no outgassing, no coma. So what was pushing it? Some scientists proposed that maybe there was ice beneath the surface, releasing gas in ways we couldn't detect. Others suggested it could be made of hydrogen ice, which would be nearly invisible. But these ideas require special conditions, specific compositions that, frankly, feel like we're bending the data to fit comfortable explanations. And then there's Abraham Loeb, the Harvard astrophysicist who suggested something that made headlines around the world. What if it's artificial? What if Oumuamua is a light sail, a thin, reflective sheet propelled by starlight, built by an alien civilization? The idea isn't as crazy as it sounds. We've designed light sails ourselves. Japan's Icaros probe successfully demonstrated solar sailing back in 2010. If we can conceive it, why couldn't another civilization, perhaps millions of years more advanced, have actually built one? The scientific community largely pushed back on this hypothesis, not because it's impossible, but because we're trained to exhaust natural explanations first. Occam's razor tells us the simplest explanation is usually correct. But here's the thing about Occam's razor, it assumes we understand what simple means in a universe full of phenomena we've never encountered. And simplicity is relative to your frame of reference. To a medieval peasant, thunder was the anger of gods, simple, intuitive, obvious. To us, it's the rapid expansion of air, heated by lightning discharge. More complex? Absolutely, but also correct. So when we say alien spacecraft is less likely than natural phenomena, we're really saying alien spacecraft doesn't fit our current framework as easily. That's fine. That's good science. But let's not pretend it's the final word. Because here's what keeps me up at night. What if we're doing exactly what those medieval peasants did? What if we're clinging to comfortable explanations because the true answer is so far outside our conceptual framework that we literally can't see it? Think about this. Every time in history we've expanded our understanding of the universe, we've discovered we were more provincial, more limited in our thinking than we realized. We thought Earth was the center of everything. Wrong. We thought our galaxy was the entire universe. Wrong. We thought the universe was static and eternal. Wrong. Each time, the reality was stranger, grander, more unsettling than we imagined. So why would now be different? Why would we suddenly have arrived at the limits of cosmic strangeness? Here's another angle that fascinates me. Let's talk about evidence and what qualifies as good evidence. In science, we have standards. We want reproducible results, clear data, peer review, all essential. But these standards were developed for laboratory science, for phenomena we can control and repeat. UFOs, by definition, don't cooperate with our protocols. They appear unexpectedly. They don't hold still for measurement. They don't repeat on command. So we're left in this awkward position where the phenomena might be real, but it refuses to behave like a good scientific subject. It's like trying to study lightning before we understood electricity, when your only tool was eyewitness accounts and the occasional scorched tree. The phenomenon was real, but the evidence was frustratingly indirect. And yet, people kept reporting it, consistently, across cultures, across centuries, until finally we developed the tools and frameworks to understand it properly. Maybe that's where we are with UAPs. Not in the final chapter, but in the frustrating middle part where we know something's there, but we don't yet have the right questions, let alone the right answers. And here's what keeps me up at night. What if the phenomenon itself is designed to be just ambiguous enough? Think about how you'd study an ant colony without disturbing it. You wouldn't land a spaceship in the middle of it. You'd observe from a distance, maybe interact in ways that seem random to the ants, but are perfectly controlled from your perspective. That's the unsettling possibility we have to consider, that the inconsistency isn't a bug, it's a feature. The vagueness, the way these things seem to dance right on the edge of undeniability and deniability, might be intentional. A civilization advanced enough to traverse the cosmos would certainly be advanced enough to control exactly how much of themselves they reveal. I've spent decades thinking about contact scenarios, about what first contact might look like, and I always come back to one uncomfortable truth. We're probably not ready for clear, unambiguous contact. Not psychologically, not sociologically, and definitely not politically. Maybe whatever's out there knows this. Maybe they're showing us just enough to prepare us, to slowly acclimate us to a reality that would otherwise shatter our worldview. Or maybe I'm giving them too much credit. Maybe they're just passing through, and we're about as interesting to them as that ant colony is to us. We notice it, we might even study it for a moment, but we're not going to reorganize our entire civilization to make proper diplomatic contact with the ants. But here's where it gets really interesting. Let's say for a moment that some of these encounters are real, that there is something physical, technological, and non-human operating in our skies and oceans. The immediate question becomes, what do they want? And that question, my friends, might be based on a completely flawed assumption. It assumes they want something at all. We assume intention because we are creatures of intention. Every action we take for a reason. We're hungry, we eat, we're cold, we seek shelter, we're curious, we explore. But this is biological programming refined over millions of years of evolution. Our wants and needs are hardwired into our DNA. But consider for a moment an intelligence that didn't evolve through natural selection. An intelligence that was designed or that emerged from pure mathematics or that exists in a state so foreign to our own that the very concept of wanting doesn't apply. I'll give you an example that might help. Think about a river. A river carves through rock, creates valleys, shapes entire landscapes. It looks purposeful, doesn't it? It looks like the river wants to reach the ocean. But the river has no wants. It has no desires. It simply follows the laws of physics. Gravity pulls water downward. Momentum carries it forward. The path of least resistance determines its course. Now, imagine an alien intelligence that operates on similar principles, not driven by biological imperatives or emotional needs, but by something more fundamental. Perhaps they're following patterns embedded in the mathematics of the cosmos itself. Perhaps they're solving equations we can't even comprehend. Their presence in our solar system might not be intentional at all in any way we'd recognize. They might simply be going where the geometry of space-time tells them to go. This troubles us deeply. We want to negotiate. We want to communicate. We want to establish common ground. But how do you negotiate with the river? How do you reason with the tide? And here's where it gets even stranger. What if their consciousness, if we can even call it that, operates on timescales completely incompatible with our own? Think about this carefully. When you observe an ant colony, how long do you watch? Minutes? Maybe an hour if you're particularly fascinated? To you, you've witnessed an entire epic ants marching, fighting, building. But to the colony, operating on a timescale of seasons and years, you were there for merely a heartbeat. You blinked into existence above their world and vanished just as quickly. Now flip the perspective. What if we are the ants? An advanced civilization might experience time so differently that our entire recorded history, from the first cave paintings to the moon landing to this very moment, occurs in what they perceive as an afternoon. They might have observed Earth, seen nothing but geological processes, and concluded, no intelligence here, just slow chemical reactions. By the time they decided we weren't interesting and looked away, 1,000 human generations had lived and died. Or consider the opposite extreme. What if their consciousness operates so rapidly that they experience subjective millennia in what we call a second? To them, trying to communicate with us would be like us trying to have a conversation with a mountain. They'd send a signal, wait what feels to them like eons for our response, and assume we're simply part of the landscape. Interesting rocks, perhaps, but not minds. This isn't science fiction. This is a fundamental problem in information theory and cognitive science. Communication requires synchronized timescales. A civilization existing on quantum timescales, where thoughts complete in nanoseconds, would find us incomprehensibly slow. One using computation at near absolute zero temperatures, where quantum decoherence is minimized, might think on timescales of centuries for a single thought deep, profound, but glacial. The universe might be teeming with consciousness, all of it real, all of it vibrant, none of it able to recognize the others because they're all singing songs at completely different frequencies. We're listening for a voice at 440 Hz while they're broadcasting at 0.0001 Hz, a signal so slow it would take human lifetimes just to say hello. This is what I call the temporal horizon problem. It's not just about distance or technology, it's about the fundamental rate at which information can be exchanged between minds operating at vastly different computational speeds. Think of it this way. When you have a conversation with another person, you're both running on wetware that processes information at roughly the same speed. Your neurons fire at similar rates. Your perception of time aligns. But now imagine trying to have a meaningful dialogue with an intelligence that experiences a subjective year in what you perceive as a microsecond. By the time you've formulated your first word, they've lived through entire epochs of thought, developed new philosophies, forgotten you existed, and moved on to other concerns. This creates what I call temporal isolation barriers. You can't collaborate, can't build relationships, can't even verify that communication occurred. The slow intelligence sends a message, "Hello, we come in peace." By the time the fast intelligence receives it and composes a reply from their perspective, just a moment later, thousands of years have passed for the sender. They're no longer there. Their civilization has risen and fallen. Their star might have gone cold. And here's what really keeps me awake at night. We might already be receiving these messages and not even know it. The cosmic microwave background radiation that we measure as the echo of the Big Bang? What if embedded in those temperature fluctuations, in patterns that would take millions of years of continuous observation to decode, is a message from an intelligence operating at cosmological timescales, a consciousness so vast and slow that it thinks in terms of galactic rotations, that experiences the birth and death of stars the way we experience heartbeats? We'd never know. We're like mayflies trying to read a message carved into a sequoia tree, a tree that's still in the process of growing out the letters, one ring per century. The complete message won't be visible for 10,000 years, but will be long gone. And here's what haunts me late at night when I'm staring at equations that refuse to resolve. What if we're not even looking in the right dimensions? Think about it. We search for radio signals, optical flashes, megastructures that block out stars. All of this assumes civilizations operate in the same physical space we perceive. But what if advanced intelligence doesn't stay in our three spatial dimensions plus time? String theory suggests there may be 10 or 11 dimensions of reality. Most are curled up so small we can't perceive them, like how an ant on a telephone wire experiences a one-dimensional world, unaware of the wire's circular cross-section. What if a sufficiently advanced civilization learns to unfold those dimensions? To step sideways out of our observable universe into a parallel brain, a higher dimensional space where they can manipulate reality in ways that look like magic to us? From their perspective, we'd be the Flatlanders' two-dimensional beings pressed against a sheet of paper, completely unaware of the three-dimensional beings moving above and below us. They could be right here, right now, watching us with bemused patience, and we'd have no way to detect them. Our most sophisticated instruments are designed to measure phenomena in our dimensional framework. We can't build a detector for something our physics hasn't even confirmed exists. Or consider this: what if consciousness itself is the barrier? We assume intelligence is substrate independent, that whether you're made of carbon neurons or silicon circuits or quantum foam doesn't fundamentally change the game. But what if it does? What if biological consciousness operates on principles we don't understand, and artificial consciousness operates on completely different principles? And somewhere out there, there are forms of awareness so alien they don't even register as alive to us. We look for intentional signals, but intention requires a kind of consciousness that shares some common ground with ours. Purpose, goals, the desire to communicate. What if there are vast intelligences out there that experience reality in a way so foreign that the concept of sending a message is literally meaningless to them, like asking a forest to write you a letter? Or imagine this: we're looking for technological signatures, right? Radio waves, megastructures, Dyson spheres. But what if a truly advanced civilization has moved beyond technology as we understand it? What if they've learned to manipulate reality at such a fundamental level that their presence looks like nothing, or like everything? What if they're embedded in the quantum foam itself, woven into the fabric of space-time in ways our instruments literally cannot distinguish from background noise? There's a concept I find both beautiful and terrifying. The idea that consciousness itself might be the ultimate technology, not machines that think, but thought that builds. Imagine a civilization that has learned to structure matter and energy through pure information, through consciousness alone. No rockets, no telescopes, no transmitters, just mind interfacing directly with the quantum field, reaching out across the cosmos in ways that to us would be completely invisible. We'd be looking for their tools while they've become pure process. This touches on something deeper, something that keeps me awake at night. The possibility that intelligence, as it advances, converges towards something we can't recognize. Not because we're not smart enough, but because recognition itself requires shared context. You know, when you look at an ant colony and you see amazing organization, chemical communication, collective intelligence, but you don't see individual ants contemplating the meaning of their existence. There's an observer problem there. The ants can't conceive of you, even though you're right there, watching them. Your mode of being is so orthogonal to theirs that you might as well not exist. What if we're the ants? What if the galaxy is teeming with intelligences operating on timescales of millions of years, thinking thoughts that take millennia to complete, perceiving in dimensions we can't access? We're listening for a conversation, but we're listening on a timescale of decades. Imagine trying to understand a movie when you can only see one frame per century. The story would be completely incomprehensible. But here's what really keeps me awake at night. What if we're not listening at the wrong speed? What if we're looking in the wrong dimension entirely? Think about this for a moment. We live in 3 spatial dimensions plus time. Our physics, our mathematics, our entire understanding of reality is built on this 4-dimensional framework. But string theory suggests there may be 10, 11, even 26 dimensions curled up at scales too small for us to perceive. What if advanced civilizations have learned to operate in these higher dimensions? To them, our 3-dimensional space might be like a sheet of paper. They could be right next to us, surrounding us, even passing through us, and we'd never know. We'd be like the inhabitants of Flatland, a 2-dimensional world, completely unable to perceive beings that exist in the 3rd dimension. A sphere passing through their plane would appear as a circle that mysteriously grows and shrinks. They'd see the effect, but never comprehend the true form. Now scale that up. A civilization operating in 5, 6, 7 spatial dimensions would leave traces in our 3-dimensional world that might seem like magic, or miracles, or simply the random noise of quantum fluctuations. We might be surrounded by their technology, their cities, their entire civilization, and to us it would be invisible, incomprehensible, like trying to show a Renaissance painting to an ant. I'm reminded of a conversation I had with a colleague who studies dark matter and dark energy. These substances make up 95% of the universe, yet we can't see them, can't touch them, can barely detect them. We only know they exist because of their gravitational effects on the matter we can see. What if some of that dark matter isn't matter at all? What if it's the shadow, the gravitational footprint of civilizations operating in dimensions we can't access? It sounds like science fiction, I know. But 50 years ago, so did black holes. 100 years ago, so did quantum entanglement. The universe has a habit of being stranger than we imagine, stranger perhaps than we can imagine. And so I maintain what some call irrational optimism, because history teaches us that the impossible has a peculiar way of becoming inevitable. When I was young, my hero was Einstein, not just for his equations, but for his courage to imagine what others couldn't see. He pictured himself riding alongside a beam of light, a thought experiment that changed everything. No lab, no telescope, just pure imagination, disciplined by mathematics. That's the tool we need now, imagination tempered by rigor. Because here's what keeps me working late into the night. We might be closer than we think, not centuries away, not even decades, perhaps just one breakthrough away from seeing the pattern. One elegant equation that makes it all click into place. Think about Maxwell's equations, 4 simple lines that unified electricity and magnetism. Before Maxwell, they seemed like completely separate phenomena. After Maxwell, we realized they were 2 faces of the same coin, electromagnetism, one force, not two. And from that unity came radio, television, computers, the entire electronic age. What if consciousness is waiting for its Maxwell? What if there's a unified field theory of mind that will make us slap our foreheads and say, "Of course, how did we not see it?" I've dedicated my life to finding unifying principles. String theory attempts to unify all the forces of nature into one elegant framework. Why should consciousness be any different? Why should the subjective be forever divorced from the objective? Maybe it's not. Maybe the hard problem of consciousness isn't hard because it's mystical. Maybe it's hard because we're missing one key insight, one measurement we haven't made, one dimension we haven't considered. And when we find it, when we finally crack the code, the implications will cascade through every aspect of human existence. Imagine understanding precisely how memories form and why they fade. Not just the chemistry, but the complete physics of remembrance. We could preserve the memories of those we love. We could eliminate traumatic memories while keeping the lessons they taught. We could enhance learning, deepen empathy, expand the very capacity of human experience. Imagine treating depression, schizophrenia, and Alzheimer's, not with blunt chemical hammers, but with surgical precision, because we'd finally understand the symphony, not just the instruments. Imagine communication that transcends language. Direct mind-to-mind transfer of concepts, feelings, entire frameworks of understanding. Not telepathy in the mystical sense, but technology grounded in the physics of consciousness. We're already seeing the first primitive versions of this technology, brain-computer interfaces that allow paralyzed patients to type with their thoughts. Neural implants that restore basic communication to those who've lost their voice. These are the Wright brothers' first flights compared to what's coming. Within decades, we could have devices that translate your neural patterns into digital signals that another brain can decode. You think of a sunset, you witness the golden light, the feeling of peace, the exact hue of orange against purple clouds, and someone else experiences it, not a description, not a photograph, the actual qualia, the subjective experience itself. This fundamentally rewrites human connection. Arguments dissolve when you can truly feel what the other person feels. Prejudice becomes impossible when you can experience life through someone else's neural architecture. Empathy stops being an exercise in imagination and becomes direct transmission of experience. But here's where it gets profound. If consciousness can be transmitted, can it be copied? Can it be stored? This isn't science fiction. It's a serious question in computational neuroscience. If your pattern of consciousness is information, and information can be duplicated, then the hard barrier between self and other begins to blur. Imagine backing up your consciousness like you back up your phone. Imagine merging temporarily with another mind to solve complex problems, 2 consciousnesses becoming one superintelligence, then separating again. Imagine uploading aspects of your expertise directly into someone else's brain, not teaching them physics, giving them your intuitive understanding of physics. The philosophical implications are staggering. What is identity when consciousness becomes fluid? What is death when your pattern can persist independent of your biological substrate? These aren't abstract philosophy questions. They're engineering challenges we'll face this century. And it's not just human to human. We might achieve communication with other forms of intelligence. Imagine a neural interface that lets you experience what your dog experiences, their olfactory world, their emotional simplicity, their genuine joy. Imagine connecting with an artificial intelligence not through a screen, but through direct neural link, thinking alongside an intelligence that processes information fundamentally differently than you do. This is consciousness breaking free from its biological prison. And with that freedom comes both extraordinary promise and profound danger. The promise is intoxicating. We could solve problems that currently seem insurmountable. Climate change models that would take decades to compute could be processed in hours through quantum-enhanced neural interfaces. Medical diagnoses that miss rare conditions could be caught by AI systems that remember every case ever recorded, interfacing directly with doctors' intuition and experience. Scientific breakthroughs that require connecting disparate fields, quantum mechanics and biology, neuroscience and artificial intelligence, could happen when human creativity merges with machine processing power. But here's what keeps me awake at night. Consciousness isn't just about intelligence, it's about values, ethics, identity. When we begin to merge human and artificial minds, whose values dominate? If an AI can process 1,000,000 scenarios in the time it takes you to have one thought, how do you maintain human agency in that partnership? You might think you're making a decision, but really, you're just ratifying what the faster intelligence has already determined is optimal. And there's something even more unsettling. Throughout human history, we've assumed consciousness was sacred, unique, the thing that separates us from mere matter. But what happens when we can build it, copy it, edit it like software? Do you still have rights when your consciousness can be paused, saved, restored from backup? If we can upload a mind, are there now two of you? Which one is real? Which one has your identity, your memories, your soul, if such a thing exists? I've spent my career exploring the boundaries of physics, the edge cases where reality behaves in ways that defy common sense. But this, the engineering of consciousness itself, this pushes us beyond the boundaries of physics into territory that's part technology, part philosophy, part theology. We're not just building better tools, we're redefining what it means to be human. And the transition is happening faster than we can adapt. Our ethics, our laws, our social structures, they're all built on assumptions about consciousness that are about to become obsolete. And here's what keeps me up at night. We're not just uploading consciousness, we're fragmenting it, distributing it, creating versions of ourselves that exist simultaneously in multiple locations, multiple substrates, multiple realities. Think about what that means. Right now, your consciousness is unified. It's happening in one place, at one time, with one continuous narrative. You wake up in the morning, and you're the same person who went to sleep. Your memories form a coherent thread. But what happens when there are three versions of you? One biological, one digital, one hybrid. What if they have different experiences, different memories? The biological, you falls in love. The digital, you discovers a groundbreaking theorem. The hybrid, you experiences something neither biology nor silicon could produce alone. Which one is really you? Or are they all you? And if they are, what does you even mean anymore? We're entering an era of consciousness pluralism, and we're not ready for it. Our entire legal system is built on the assumption that one body equals one person equals one set of rights. What happens when one person exists in 17 locations simultaneously? I've consulted with legal scholars trying to anticipate this. They're scrambling. If digital you commits a crime, who goes to jail? If biological you signs a contract, are all your copies bound by it? If one version of you wants to die, do the others have to consent? These aren't philosophical exercises anymore. They're constitutional crises waiting to happen, and they're coming sooner than anyone wants to admit. But here's the deeper question, the one that haunts me. Will we lose something essential in the transition? There's a theory in neuroscience that consciousness isn't just what the brain does, it's how it does it. The messy, inefficient, evolved way our neurons fire. The quantum effects in microtubules. The role of embodiment, of having a body that feels hunger, pain, desire. What if consciousness isn't substrate independent? What if silicon can create something that looks like consciousness, acts like consciousness, but is fundamentally different? Not necessarily worse, just different. Like how artificial vanilla tastes similar to real vanilla, but isn't quite the same. We might be trading the human experience for something else, something we don't yet understand, and once we make that trade, there's no going back. Now, I want you to think about something that keeps me up at night. When I look at the trajectory of AI development, I see something that resembles the early days of nuclear physics. In the 1,930 seconds and 40 seconds, we unlocked the power of the atom. We created something magnificent and terrifying, and we did it before we fully understood the implications. The scientists at Los Alamos knew they were building something powerful, But did they truly comprehend what they were unleashing? Could they have predicted the Cold War, the nuclear arms race, the decades of existential dread? Some of them tried to warn us. Oppenheimer famously quoted the Bhagavad Gita, "Now I am become death, the destroyer of worlds." But by then, it was too late. The genie was out of the bottle. We're at a similar crossroads with AI. But here's what makes this moment even more precarious. Nuclear weapons, as terrible as they are, require massive infrastructure, rare materials, and nation-state resources. AI requires a server, farm, and electricity. The barrier to entry keeps dropping. What once required a government budget can now be done by a well-funded startup. What required a team of PhDs can now be accomplished by clever undergraduates. This democratization sounds wonderful in theory, knowledge for everyone, innovation unleashed. But it also means we're racing ahead without the institutional safeguards that at least partially contain nuclear technology. There's no International Atomic Energy Agency for AI, no treaties limiting its development, no comprehensive oversight. And here's the part that really troubles me. We're not just building tools anymore. We're building entities that can improve themselves. That's fundamentally different from any technology that came before. A nuclear bomb doesn't wake up one day and decide to redesign itself to be more powerful. A car doesn't teach itself to drive better. But AI systems, they learn, they adapt, they evolve. But here's what's truly remarkable. They're doing this without consciousness, without the existential burden of knowing they're alive. They simply times our asterisk. And perhaps that's the ultimate lesson these silent witnesses offer us. In our relentless pursuit of meaning, we've created elaborate philosophies, religions, entire civilizations built around answering the question, asterisk, why are we here? Asterisk. Trees never ask that question. They just grow. They reach, they adapt, they connect, they give. There's a profound wisdom in that simplicity, a kind of enlightenment we've spent millennia trying to recapture through meditation, through spirituality, through countless self-help books promising to teach us how to just be. But trees? They've been masters of being since before mammals walked the earth. I've spent my career exploring the cosmos, searching for alien intelligence among the stars. But standing in that redwood forest, I realized we've been looking in the wrong place. The alien intelligence isn't out there, it's right here, living alongside us, invisible in plain sight because it operates on frequencies we've only just begun to detect. These organisms experience time differently, communicate differently, solve problems differently. They've built a civilization, if we can call it that, based not on competition and conquest, but on cooperation and connection. Imagine what humanity could learn if we truly listened. What if our future cities were grown, not built? Living structures that breathe, that clean their own air, that heal their own wounds. We're already moving in that direction. Architects are designing buildings integrated with living plants. Engineers are developing bioconcrete that repairs its own cracks using bacterial limestone. We're beginning to see what indigenous peoples have known for millennia. Trees aren't resources to be exploited. They're partners in survival. And here's something that will absolutely astound you. We're on the verge of a revolutionary partnership between trees and technology that could redefine our entire civilization. Scientists in Japan have developed a method to make wood transparent, not metaphorically, but literally. By removing lignin and replacing it with resin, they've created a material stronger than glass, biodegradable, and completely renewable. Imagine skyscrapers with walls made of transparent wood, buildings that are simultaneously alive and shelter, photosynthesizing while providing protection. But we're going even further. Researchers at MIT have embedded carbon nanotubes into living plants, essentially giving them superpowers. These augmented plants can detect chemical weapons, environmental toxins, even the early molecular signatures of explosives. Picture a forest that doesn't just purify air, it actively monitors threats, communicates dangers, becomes a living sensor network protecting entire cities. We're not replacing nature with technology, we're finally learning to merge them. And then there's the most mind-bending possibility of all. What if we could encode data directly into tree DNA? Scientists have already stored digital information in bacterial DNA. Entire books, photographs, even films compressed into genetic code. Trees live for thousands of years. Imagine using them as biological hard drives, preserving humanity's knowledge not on fragile silicon, but in the living genome of forests. A single grove could contain our entire cultural heritage, automatically backing itself up through reproduction, self-repairing through natural processes, the Library of Alexandria, but impossible to burn. This is what the future looks like when we stop trying to conquer nature and start collaborating with it. We're entering an era where the boundary between biology and technology dissolves completely, where a building isn't just constructed from nature, it is nature. Where a city isn't separate from the ecosystem, it is the ecosystem. The question isn't whether we can do this. The science is already here. The question is whether we'll choose this path before it's too late. Because make no mistake, the clock is ticking. We're in a race between our innovation and our destruction, between our wisdom and our recklessness. But here's what gives me hope. For the first time in human history, we actually understand what we're losing. We can see the intelligence we've been destroying. We can measure the value we've been ignoring.